Thank you, Matthew. Good afternoon, everyone. Thank you for the interest in my research. And my presentation will be about evaluating biologicals for the control of false codling moss, Tamatutebeo liquidreta. So, false codling moss, or FCM, is a serious pest of citrus, stone fruit, and table grapes. Infestations result in yield loss and in a loss of market access due to its phytosanitary status. Larvae are internal feeders where they are protected from contact insecticides, but once mature, the larvae drop to the soil to pupate and to complete its life cycle. It is also here in the soil where they are susceptible to soil pathogens such as entomopathogenic nematodes and fungi, and that is what this presentation will be about. So most of you are familiar with EPNs, with the life cycle of EPNs and EPFs, so I will not be discussing it in this presentation, but if you have any questions, you are more than welcome to ask me afterwards. So with the EPN strain Rimba yergelemense was produced using in vitro liquid culture technique using Erlenmeyer flasks, and it was formulated in cellulose and applied in the field at a concentration of 20 IJs per square centimeter or 2 billion IJs per hectare. The EPF Metrisium brunnium was selected. It was also cultured in vitro using a biphasic technique to produce dry spores, which was then formulated in twin. It was applied at a concentration of 1 million spores per square centimeter or 10 trillion spores per hectare. These two entomopathogens were also applied in combination. Important to note here that the EPN was applied at 5 IJs per square centimeter, which is 1/4 of the dose in the EPN-only treatment with the same EPF concentration. Water was applied using, the control was applied using water only. So just some quick photos. On the left is a FCM larvae in sieved orchard soil in a hockey puck, which was covered with a metal sieve at the top and bottom to prevent their escape, and it was buried underneath apricot trees about 5 centimeters beneath the soil. Treatments were applied with a watering can. So on to the results. The EPN and combination treatments resulted in high mortality above 75% after 5 days in the field and 2 days at 25 degrees Celsius incubated relative to the control and to the EPF treatment. When looking at the cadavers were then assessed for the presence of nematodes and fungi. There were more nematodes in the EPN-only treatment than in the combination treatment. However, the EPF sporulation were extremely low. Also, the nematodes in the nematode treatments were quite few, and they were in various stages of decay, which was quite surprising. But if you look at soil temperature, the orchard soil temperature never exceeded 20 degrees Celsius, which is quite cool. So at 25 degrees Celsius, EPF takes about 5 days to achieve mortality and EPN 2 days. But at these lower temperatures, we can expect that to take considerably longer. The nematodes may be able to penetrate the insect, but the bacteria might not be able to grow inside, essentially starving the nematode. So we did a follow-up study in the laboratory where we inoculated final instar FCM larvae with the same EPN species that was used in the field trial, and we incubated it at 14 degrees, 20 degrees, and 26 degrees to assess the influence of temperature. And this graph shows the mortality per treatment, per temperature, and per repetition. They were incubated for 7 days at that set temperature and an additional 2 days at 25 degrees Celsius. And you will notice that at 20 degrees and 26 degrees, high mortality was achieved after only 2 days. However, at 14 degrees, mortality was only achieved after 7 days, which is also when the larvae were incubated at 25 degrees. So let me just check here. So it is important to note then that lost my place here a little bit. So it is important to note that these lower temperatures, that even in the 14 degrees, that the cumulative mortality was still lower than the 20 and 26 degrees. So it is important to keep that effect in mind when considering the use of entomopathogens for the use in orchards which are grown in cooler time of the season, such as citrus. Yeah, if you have any questions, you're welcome to email me or contact my supervisors. And I would also like to thank Houtkrou, SATI, and the SRIP initiative by the NRF for funding this research. Thank you.